All right, welcome back. This is Energy from Biomass. This is 6.7. Our learning objectives for today are to describe the effects of the use of biomass in power generation on the environment and to describe potential responses or approaches to environmental problems. So first, I just want to describe what biomass is, and then we're going to talk about the two different forms of biomass and then subsets of those. So biomass is plant or animal material used as a fuel to produce electricity or heat. Technically, biomass can be used as a fuel directly, which is really the value that it has across the world, especially in more developing countries. So when we talk about biomass being used as a fuel directly, we're generally talking about producing heat energy versus electricity. But people also use the terms biomass and biofuel interchangeably, so we're going to discuss the differences between those. Now, there's solid biomass and biofuels. Biofuels are going to be things like biodiesel and ethanol, and those aren't going to be able to be burned directly. Those are going to require some sort of transformation in order to become useful. And those are going to be different than biomass, like charcoal, wood, manure, or peat, which are basically going to be usable from the get-go. And those are all going to be used to produce heat energy in some form or another, and we'll discuss all of these. So all of these things, they are considered biomass. So because they are living things or once living things, just like fossil fuels, they contain carbon. So when we burn biomass, we are eventually contributing to carbon dioxide emissions in the atmosphere. So the question is, is this really better than burning a fossil fuel? Because really we're burning the same thing. And so it really kind of depends on how you view it. Burning biomass is really a difference between burning modern carbon versus fossil carbon. Remember, modern carbon is carbon that's going to naturally recycle within our atmosphere because it's stored in something that is going to recycle it very quickly. For instance, the carbon stored in grasses or in trees. That is carbon that isn't going to be stored for millions of years. It's carbon that's going to be stored for the lifetime of that particular plant. So we would consider that to be modern carbon in general. So are we really contributing to greater amounts of carbon dioxide in the atmosphere? Not really. We're speeding along the process of modern carbon transferring, but it is not like pulling fossil fuels out of the ground and contributing that fossil carbon into our modern carbon storage. So sometimes we view the burning of biomass as being carbon neutral because those plants that were going to die eventually anyway, we're just releasing that carbon a little prematurely, and eventually that carbon will be absorbed by more plants that will replace those plants. So we would consider it almost a carbon neutral burning of carbon, as long as the plants that we're planting or the plants that we're burning are being replaced by more plants. And that's where we kind of run into issues and that's what this says, basically. It depends on how the land is treated after the biomass is harvested. So if we cut down a bunch of trees to use those as biomass, presumably if we plant more trees, it would be a carbon neutral activity. But if we're not doing that, then we wouldn't consider that to be carbon neutral, and we would just be adding more directly to the amount of carbon dioxide in the air. So just a reminder on the first law of thermodynamics and where energy is really coming from. So the energy in biomass is just energy that is coming from the sun. This energy has just been converted during the process of photosynthesis, and that's the energy that we're burning. So again, the first law of thermodynamics, we're not creating energy, we're just changing energy. So biomass as a source of energy. This is going to be the leading source of renewable energy worldwide. This is because it's the most accessible and you don't need any infrastructure in order to use this type of energy. It's used both in developing and developed countries. It doesn't need to be converted or refined to be used as an energy source. And it's considered renewable because we can create more of it within the lifespan of a human. So we can always grow more trees. So we can always make more wood, right, to be used for energy. Now, again, because the whole beauty behind biomass is it can be used directly without any type of pre-existing infrastructure. And so generally it's going to be used for heating or cooking or things like that. It's generally going to exist in its solid state. And it's going to be things like wood, peat, charcoal, manure. All of those things can essentially be burned directly and can be used for heating or cooking. But overall, it's going to be a source of heat energy. You're probably familiar with all of the ones on here except for maybe charcoal and the process for which charcoal forms. You're familiar with wood. You just learned about peat. You know what manure is. This would be like cow feces that can be burned for energy. Charcoal, you've probably heard of, but you may not know what it is. This is actually a picture of charcoal right here. Charcoal is really lightweight. So like if you were to look at this actually looks like a really charred piece of wood, which is essentially what charcoal is, but it'd be really lightweight. And if you crushed it in your hand, it would almost turn into a powder immediately. Charcoal is something that you can make yourself. It's burning something like wood at a really high temperature without any oxygen present. So it's what we'd call an incomplete combustion reaction, which we'll learn about a little bit later. But what basically remains behind after you burn wood in this very low oxygen setting at a very high temperature is this very carbon dense material that we call charcoal. And so people in developing countries and even people here in the United States will use charcoal mostly for cooking, because when you burn charcoal, there actually isn't any smoke. There's no flame, there's no smoke. Really all you get, well, you will get smoke. I shouldn't say that. You do get a very distinct smoke. It's less smoky than, I guess, a fire where you're burning wood. So you do get a smoke, but it's a different type of smoke than you would see if you were just burning wood directly. But it doesn't have a flame, which is really the biggest difference. It's just going to be a really high energy heat. So that's kind of what makes it good for cooking. It does, that smoke that it does release has a very distinct smell to it, and taste actually. So this is why some people like cooking on charcoal barbecues, or they buy those charcoal briquettes for charcoal barbecues. It gives like a very distinct taste to your food. So some people like to grill meat on charcoal barbecues because it gives it a very distinct taste. But yeah, so you can buy charcoal, which is what a lot of people here in the US do. There are big companies. In fact, if you watch these YouTube videos, you'll watch a big commercial manufacturing of charcoal, and then the other video is going to be like an individual, like in a developing country, making charcoal. So it's kind of interesting. I would watch them if I were you, or maybe we'll do them in class, but they're pretty interesting. So it's an alternative to cooking. But it definitely is a lot of energy to actually get to charcoal, especially if you can't commercially buy it. So what are the pros? What are the cons? Obviously, biomass is accessible to all people. It's very inexpensive comparative to other energy sources. No additional infrastructure is needed, so you can use it directly as an energy source, and it can be used for heating and cooking, etc. The downsides, generally with burning biomass, you're going to release quite a few air pollutants. So carbon dioxide is an obvious one. Carbon monoxide may seem less obvious, but carbon monoxide is going to be is a byproduct when there is incomplete combustion of a lot of fossil fuels and these biomasses. Carbon monoxide is like an odorless, colorless gas that will suffocate you if you inhale too much of it. Basically prevents oxygen from circulating through your bloodstream. But this is problematic if you are burning biomass like inside a small house or a closed setting. If incomplete combustion is happening, you could potentially cause yourself to get sick from inhaling too much of this. Nitrogen oxides, these are a type of fossil fuels that we'll learn more about in our air pollutant unit. Particulates, that means like actual pieces of matter floating around in the air that could cause like lung irritation. And they are VOCs. These are volatile organic compounds. VOCs are generally compounds that have really strong smells to them. So most of these things, when you burn them, have like a very strong odor associated with them, which will give you like nose and lung irritation, eye irritation, etc. Again, if we're typically burning these indoors, especially if we're trying to generate heat energy because we're living somewhere cold or we're cooking, and of course doing all of that, VOCs, particulates, and carbon monoxide all inside a very small area, that could be problematic for humans to inhale all of that. And like I said, if you're inhaling too much carbon monoxide, it could even cause death. And then we already talked about this, but if you are over harvesting trees for fuel, that could cause a massive amount of deforestation. So again, depending on how you're treating the land, if you're not replanting trees, then biomass isn't necessarily like a sustainable option. So that was it for solid biomass, or biomass for energy. Now we're going to talk about biofuels, which again are a subset of biomass. Biofuels are going to be liquids. So what we were just talking about generally tends to be in a solid state. Biofuels are liquid fuels that generally come from plants. And they're going to be substitute for things like gasoline or diesel, which is predominantly what powers most combustion engine vehicles around the world. So the two that we're going to focus on are ethanol and biodiesel. And you've actually probably heard of these. So ethanol is basically converting the sugars and starches into alcohols. Generally for ethanols, we're going to be using things like corn, but sugarcane is also used, but mostly corn here in the United States. About 90% comes from corn. Typically, you're going to mix this sugar-based alcohol in with a small percentage of gasoline to create something called gasohol. Gasohol, or more commonly known as E85, is pretty much a mixture of 90% gas to 10% ethanol. E85, which is what you'll commonly see here, is actually 85% ethanol and 15% gas, which is why they call it E85. But this is, like I said, it's a fuel that's predominantly plant-based. So the alcohol in it comes from sugars, and then the gas in it comes from standard gasoline, like you would purchase at any gas station, any refined type of fuel. And then you get this gasohol or E85, whatever you want to call it. Now, again, this there's a couple kind of interesting things to think about with this. If you burn ethanol, so this ethanol that we're burning, it doesn't introduce carbon in the atmosphere during the combustion portion of you driving your car. So this is really the big buy-in for ethanol, because ethanol is an alcohol. It's fermented sugars. It's not it's not like burning the same thing as burning like biomass, minus the 15% gas or 10% gas that you're putting in, right? So this is technically a cleaner. It's a cleaner source of energy. Which is why there's sort of this big push. Now, not all vehicles will take E85. Your car has to have this symbol on it, this flex fuel symbol. It means your car, flex fuel means it will take regular unleaded gasoline, or it will also take E85. A lot of people who have flex fuel vehicles don't actually know what a flex fuel vehicle is and don't know what E85 is. So you may have this car and you may not know that you can put E85 in it, but it's also hard to find E85 gas stations. They're really common in the Corn Belt portion of the United States, because where a lot of corn is grown, there is more ethanol-based fuels being made. So it's more common for people out there to use it. The biggest downside to E85, it is much cheaper than like a regular gasoline, but it has a very low energy return on energy investment. So you'll probably have a much lower fuel economy. You'll be fueling up much more often. So even though the price per gallon is going to be cheaper, you may end up putting more gasoline in your car, like more frequently. So the cost analysis of that may shift. Now you can tell this is in California just based on the prices of this gasoline here. But we're, in the 4 or 5 range, right? So we'll talk about a little bit more the downsides to this. But one of the biggest things, and hopefully your mind went to this, is if we're using corn to make alcohol, essentially fermenting corn into an alcohol to be used for gasoline, think about all the land that's being used to grow that corn that corn isn't being consumed by people. So we talked about agriculture in our last unit and how much of an impact agriculture has. But think about how much land is being used to grow corn that just gets turned into a fuel source. So really you have to think about the energy investment in terms of not just like your car, but also how much energy went into like growing the corn that then got converted into an alcohol. So that is not necessarily the most, it's like kind of a trade-off of where your energy is going. Now the next one is biodiesel or B20. This is extracted and chemically modified oil from plants. So the last one was fermented sugars. This one is extracting an oil. Mostly we're using soybeans, palm oil, rape seeds. These are rape seeds. These can be used in any diesel car, so any car that runs on diesel. You don't need any type of modification. I should have clarified that on an ethanol vehicle. You can't just put E85 in any car. You have to either have a flex fuel vehicle or a vehicle that's specifically designed to run off ethanol. Not every combustion engine is designed to do this. Biodiesel can be used by any diesel-based engine. So anything that runs on regular diesel can also run on biodiesel. Biodiesel is 80% gasoline, 20% biofuels or biodiesel. It's this oil that can be refined and combined with petroleum to be used in a car. Again, this just decreases the level of carbon dioxide that you are emitting in the process of using your vehicle. So pros and cons. Combustion is carbon neutral, essentially. You're burning modern carbon versus fossil carbon. It's potentially renewable because you can continually grow more of these resources depending, again, on how the land is treated. And some people really like that it can be produced domestically, so we don't have to have any type of dependence on imports. So some people like that idea. The negatives, the net energy is low. You really need more of this particular fuel in order to travel the same distance, so maybe cost isn't as great. And then, of course, the harvesting of crops for ethanol has a potential to increase more fossil fuels, increase deforestation, reduce the fertility of soil, and then less food is available to people for consumption because now we're taking that corn that can maybe be eaten by people and using it for fuels or sugar or whatever it is that we're converting into a biofuel. Now, there are a couple more sustainable options for ethanol. So one thing that people are looking into is something called switchgrass. Switchgrass is a really interesting crop because it's a perennial crop. A perennial crop means, unlike corn, which is an annual, it has to be replanted each season. Perennial crops just keep growing. So after we harvest them, more will grow forever and ever and ever as long as the land is prepared to support them. This leaves soil intact. It leaves really fertile land. It uses less fossil fuels because we don't have to go through the process of maintaining the land and replanting. So it does really well and disrupts like natural ecosystems a lot less. The problem is switchgrass has a much lower sugar content. So it's really the sugar that we're converting or fermenting into an alcohol. And so because switchgrass has much less, it doesn't yield as much of a product. So we would need more of it. But it is an option that people are looking into. Now, one other type of biodiesel, a more sustainable biodiesel option, is something called SVO or straight vegetable oil. And it's the same type of vegetable oil you would cook or bake with. It's no different. Most of the time, you can basically convert anything that's diesel run into something that will run off straight vegetable oil or SVO. You can modify your cars. There's kits, but it can be done. The problem with this is, for the most part, people who have done this are basically collecting like used vegetable oil from like fast food places, like deep fryers that, eventually they're throwing out the oil and, whatever, and that's what collects it. There is not enough deep fryers in the world to support this as like a primary fuel use for everybody. And then vegetable oil obviously comes from vegetables, so it is still coming from somewhere. So it's really only sustainable for like making use of what would normally be waste. So it's not really like, this is not the solution for the future. It's just an alternative option. I actually put this picture up here because there were like a group of, I don't know, I think it was 6 to 10 college students from a university called Middlebury, which is in Middlebury, Vermont. It's like a liberal arts school, and they actually converted this bus, and it was a diesel bus, into a bus that would run off of SVO, and they traveled 15,000 miles in this bus. This bus, by the way, only gets 8 miles per gallon, so it didn't do very well, but they were able to travel a pretty long distance, and it was actually a group of environmental science majors who kind of did this a little bit as like, hey, let's take a semester off and enjoy, but they also used it as an opportunity to travel around the United States and sort of explain to people what biodiesels were, what SVO was, and how it was kind of like a sustainable option for the future. So this was like 2004, 2008, so this was quite a while ago, but kind of interesting either way. Okay, I think that's it. Let me know if you have questions, and I'll see you in class. Thanks.